Hello guys, welcome to today's episode, and today we are going to look at probability. What is probability? Probability is a branch of mathematics that deals with the prediction of the occurrence of an event. That is, you want to know if something is going to happen or something is not going to happen. In this case, probability is governed by four basic principles that are going to help us understand probability. That is to say, the first principle is, if you want to enumerate the probability of an event, for example, event A happening, we are going to look at the number of favorable outcomes, over the total number of trials. That is to say, if, for example, you are tossing a coin, and assume you toss a coin 50 times, and each time you toss, you record the number of times the head or the tail shows up. In 50 trials, let's say, for example, the head shows up 26 times, and the tail shows up, for example, 24 times. In this case, you may want to predict the probability of the occurrence of the head. In this case, to get the probability of the head showing up, we are going to take the number of times the head has shown up, that is 26 times. We divide by the total number of trials, which are 50. That is determining the probability of the head showing up. And in this case, if you want to determine the probability of the tail showing up, it is going to be equal to the number of times the tail has shown up, which is 24. You divide by the total number of trials, which is 50. That is our first principle. Then principle number 2 is that the probability of something happening plus the probability of something not happening, the total must be equal to 1. That means the total probability space is equal to 1. That is, probability of something happening plus the probability of something not happening, the total should be equal to 1. Meaning, the probability of something happening plus not happening, the total must always be equal to 1. That is our second principle. Principle number 3, sometimes in probability, you are going to deal with mutually exclusive events. Mutually exclusive events. Mutually exclusive events are those events in which the occurrence of one excludes another from happening. For example, if you are tossing a coin, the coin has two sides, that is the head and the tail. If the head shows up, then the tail is excluded from showing up. And in this case, for mutually exclusive events, we connect the probabilities using an addition sign. That is to say, the probability of the head showing up is going to be, if you take the probability of the head showing up, then you add the probability of the tail showing up, the total should be equal to 1. What if we use a different example? For example, we have a dice. We have a dice here, and in this case, a dice is a figure that has 6 faces, namely 1, 2, 3, 4, 5, 6. In that case, meaning the other faces are in between. For example, in a single toss, you may want to determine the probability that 1 or a 3 is going to show up. Meaning, if a dice has 6 faces, it means the total number of outcomes are going to be 6. In this case, if you toss that dice once, and you want to find the probability of either getting a 1 or a 3. To get a 1 in a single set, it is going to be simply once, because we have only one face written, 1, over the total number of faces, which are a 6, or when this or is used in mathematics, it means addition. And in this case, if you want also to determine the probability of a 3 showing up, that is the first written 3 showing up, this first written 3 will only show up once out of the total possible outcomes, which are 6. Therefore, because the denominator is the same, the LCM is going to be 6, and therefore you add the numerators, you are going to get 2 over 6, which simplifies out to be 1 over 3. So what I want to emphasize is, for mutually exclusive events, we are going to join the outcomes or the probabilities using a plus sign. That takes us to the principle number 4. Principle number 4 is again going to deal with other events, that is, apart from mutually exclusive events, sometimes we deal with what we call independent events. Independent events. In this case, if for example we have 2 dice here and we toss them together, and we may want to find the probability of either a 1 or a 3 showing up. In this case, when you hear of the word and in probability or in mathematics, it means multiplication. That is, if you want to find the probability of either a 1 or a 3 showing up, or either 1 and a 3 showing up, we are going to take the probability of a 1 showing up to be simply 1 out of the total outcomes. And that is to say, it is the probability of 1 and a what? And a 3. And as we have already mentioned, it means multiplication. That is to say, 1 is only going to show up once out of 6 faces. Then of course we multiply by 3 is going to show up once out of how many faces? 6. And this gives us 1 over 36. That means if you want to find the probability of a 1 and a 3 showing up, you take the probability of a 1 showing up, you multiply with the probability of a 3 showing up, you get 1 over 36. To help us understand how these principles are applied, let us take some few questions. John is to pick a marble from either box A or box B. Box A has 5 blue balls, 6 yellow balls and 4 white balls, and box B has 3 blue balls, 6 yellow and 6 white balls. John is expected to pick on a box at random, then pick a marble from the box. Find the probability of A, John picking a yellow marble, B, John picking a blue marble. In this case, we are going to interpret the question before we do it. We have 2 boxes here. Let us say we have box A and box B. Box A contains 5 blue balls, 6 yellow balls and 4 white balls, while box B contains 3 blue balls. We have 6 yellow, that is 6 yellow and 6 white. The question is, John is supposed to pick on a box, and from that box, number 1, John is going to pick on a yellow marble. So in this case, we have 2 boxes here. The first thing that John is going to do is to pick on a box, and from that box, John is going to pick a yellow marble. So the first thing you're supposed to do is to enumerate that probability space and say, we are determining the probability of John picking a yellow marble. John picking a yellow marble. So for John to pick a yellow marble, John can either start by picking box A, and then from box A, John picks a yellow marble, or he may as well pick box B, and from that box B, John is going to pick a yellow marble. So to get the probability of picking a box, since we have 2 boxes, the probability of picking box A is going to be half. Then from that box A, John picks a yellow marble. To pick a yellow marble, we take the number of yellow marbles, then divide by the total number of balls, which are 15. Or John is also going to pick on box B, and the probability of picking box B is half, and from that box John is going to pick on a yellow marble. The number of yellow marbles are 6 out of the total 15. Or means addition, so we are going to carry out this bracket, again the other bracket before we add them. So if you look at the first bracket, we have 1 times 6 is 6 over, then 2 times 15 is 30, plus in the second bracket we have 1 times 6, which is 6, and then 2 times 15 is going to give us 30, and the total outcome here is going to be 12 out of 30, which can be simplified. That is our part A. Then on part B, we are supposed to determine the probability of John picking a blue marble. So the first thing we have to enumerate and say, we are determining the probability of picking a blue marble. So for John to pick a blue marble, the first thing he has to do is to pick on a box, and then from that particular box he picks a blue marble. So the probability of picking box A is going to be half. Then from that box he is going to pick a blue ball. That is, how many blue balls do we have? We have 5 out of the total number of balls are 15. Or you can also pick, or means addition, you can also pick on box B. The probability of picking box B will be 1, which is box B out of the 2 boxes. Then from that box B, he is going to pick a blue marble, and the number of blue marbles are 3 out of the total, which is 15. That is, the first bracket will give us 5 out of 30, plus the second bracket is going to give us 3 out of 30, and this one is going to give us 8 out of 30, which can be simplified to, that is, by 2 we are going to get 4, and by 2 we are going to get 15. And that is how easy you work out that question. We are moving to our question number 2. And question number 2 reads, Onyango is to go for an interview in a civil service job at KICC. The probability that is going to be shortlisted for the interview is half. If selected for the interview, the probability of passing the preliminary test is 2/3. In case he succeeds in the preliminary test, then his chances of passing the final test is 3/4. Using a tree diagram or otherwise, find the probability that A. Onyango passes the interview and qualifies for the job. B. Onyango did not qualify for the job. In this case, I choose to use a tree diagram so that we can be able to move faster. So Onyango is to go for the interview in a civil service job, and the probability that is shortlisted for the interview is half. So this is Onyango. Onyango is to go for an interview, and the probability of Onyango being shortlisted is actually half. That means there is also a probability that Onyango is not going to be shortlisted. From our principle number 1, happening and not happening must be equal to 1. That means the probability that he is not going to be shortlisted is also going to be half. The question continues, if selected, that means he has been shortlisted. The probability of passing the preliminary test is 2/3. That means he has been shortlisted. The probability of passing in the preliminary test is 2/3. That means the probability of failing is going to be the remaining from 2/3, that is going to be 1/3. In case he succeeds in the preliminary test, that means he has passed the preliminary test, then his chances of passing the final test is 3/4. He has been shortlisted, he has passed the preliminary test, then his chances of passing the final test is 3/4, meaning the chances of him not passing the final test, that means failing the final test, is going to be a quarter. That way now we have drawn a tree diagram to help us enumerate the chances of Onyango either securing a job or not securing that job. The first part of the question A, that is the probability that Onyango qualifies for the job. So for Onyango to qualify for the job, he must first get shortlisted. He goes ahead and passes in the preliminary test and also go ahead and passes in the final test. That means for Onyango to qualify and get that job, he must first get shortlisted. After being shortlisted, he must go ahead and pass the preliminary test, and also for him to get a job, he must pass in the final, that is passing in the final test. So, to get the probability that Onyango qualifies for the job, we are going to get the probability of Onyango being shortlisted. We multiply it with the probability of passing in the preliminary test, which is 2/3, and then we multiply with the probability of Onyango passing in the final test to arrive at the answer anyway. That is to say, a half times 2/3 times 3/4, which is going to give us 1 times 2 times 3 is going to be 6 over, that is 2 times 3, that is 6 times 4, it is going to give us 24, and this can be simplified further to simply a quarter. That means 6 goes to 24 4 times. Then part B, we are supposed to determine the probability that Onyango did not qualify for the job. Probability that Onyango did not qualify for what? For the job. Onyango will not qualify for the job, number one, if Onyango is not shortlisted, or Onyango can be shortlisted, but he goes ahead and fails in the preliminary test, or Onyango can be shortlisted, passes in the preliminary test, and fails in the final test. That means Onyango is not going to qualify for the job. So Onyango will qualify for the job if number one is going to be what? Shortlisted, or Onyango not qualifying for the job. So Onyango is not going to qualify for the job, number one, if he is not going to be shortlisted, or Onyango can be shortlisted but he goes and fails in the preliminary test, or he may also be shortlisted, he goes ahead and passes in the preliminary test but fails in the final test, test. That means this guy is not going to qualify for the job. The probability of Onyango not being shortlisted is actually half, then plus the probability of being shortlisted is also half, then he goes ahead and fails in the preliminary test, which is what? A third, or means addition. The probability also is going to rely on being shortlisted is half, he passes in the preliminary test, which is 2/3, but he fails in the final test, which is 1/4. So from our first, this is half, then we add this times this is 1/6, then plus, of course, that is going to be 2 out of, that is 24, and in this case the LCM for that matter is 24. Then 2 goes to 24, that is 12 times 1, that is 12, plus 6 goes to 24 4 times 1, that is 4, plus 24 goes to 24 once, then times 2, you are going to get 2. So the total, the LCM remains 24. Then you add the numerators, that is 12 plus 4, 16. 16 plus 2, we are going to get 18, which can simplify to be by 6 we have 3, and by 6 we have what? 4. That tells you from our second principle that the probability of something happening plus the probability of something not happening must give you what? 1. That again takes us to our question number 3. 3 balls are picked at random without replacement from a box containing 9 yellow and 6 blue balls. Using a tree diagram, find the probability that A, the balls picked are of the same color, B, 2 balls of the ones picked are yellow. In that case, we are supposed to use a tree diagram to try and work out this question. 3 balls are picked at random without replacement from a box containing. So we have a box that contains 9 yellow balls and 6 blue balls. So we are going to pick 3 balls, and in this case, if we are going to pick 3 balls, we are not going to pick all of them at once. We are supposed to pick a yellow or a blue in the first round. Since we need 3 balls, we are going to pick 3 times or to do 3 selections. That means if we are supposed to use a tree diagram, we are supposed to begin with our first selection, where we can either pick a yellow ball or a blue ball. The probability of picking a yellow ball will be equal to the number of yellow balls that we have, and in this case we have 6 blue balls. If you want to find the probability of picking a yellow ball, it is going to be 9 out of the total number of balls, which are 15. Also, the probability of picking a blue ball is going to be 6 out of 15. That is in our first pick, because in the first pick or first round we have 2 outcomes. Another pick again, we are going either to select from here or from here, meaning the second pick is going to have 4 outcomes. We are going to respect the order, that is yellow, blue, yellow, blue. In this case, if a yellow ball has been picked, it means the number of balls, since it's without replacement, the number of balls that are going to remain will be 8. We haven't touched on the blue balls, and therefore blue will remain 6. The total is going to be 14. Then here the total is 14. Then from here we can pick a blue ball. If we pick a blue ball here, the number of blue balls in the second pick will remain 5, but we haven't touched on the yellow balls along this line, and therefore we are going to have 9 balls. The total is going to be 14. That is our second pick. Since we are supposed to do 3 picks, we are going to have the third pick from here, and the total number of outcomes are going to increase to 8. That means we are going to respect the order, that is yellow, blue, yellow, blue, yellow, blue, yellow, blue, in that order. So if we have picked a yellow and a yellow, it means 2 yellow balls are out. How many yellow balls are we remaining with? We are going to remain with 7. Then yellow, we have not touched on blue balls. The number of blue balls will remain 6, but the total in this case is going to be 13. We come to this, we have picked a yellow and a blue, meaning 1 yellow is out, 1 blue is out. Meaning we are going to remain with 8 yellow balls. We have also picked a blue, and therefore we are going to have 5 blue balls. The total is going to be 13. Here we are going to have 13. So we come here. We have picked a blue and a yellow. That means yellow are going to remain to go down by 1. That will be 8. And this is blue and yellow. It means blue 1 is out. We are going to remain with 5. The total is 13. Here is 13. Then here we have picked a blue and a blue, meaning 2 blue balls are out. From 6 we are going to remain with 4, but we haven't touched on yellow balls. The yellow balls are going to remain 9, and the total in this case, that is 9, and the total is going to be 13. The total is going to be 13. That is how we represent that question on a tree diagram. For us to understand how we are going to pick the outcomes, we are going to look at these lines. We have a yellow here, a yellow and a yellow, and therefore we have yellow, yellow, yellow. Then here we are going to have a yellow, yellow, blue. We have yellow, yellow, blue. Here we are going to have yellow, blue, yellow, yellow, blue, yellow. Here we are going to have yellow, blue, blue, yellow, blue, blue. Then along this branch we are going to have blue, yellow, yellow, blue, yellow, yellow. Then of course we have blue, yellow, blue, blue, yellow, blue. Then this one is going to have blue, blue, yellow, blue, blue, yellow. Then of course the last one is going to have blue, blue, blue. That is blue, blue, and blue. Now let us look at the question. The first question that we are going to do under that is find the probability that the balls picked are of the same color. That is A. The balls picked are of the same. Probability that balls are of the same color. Balls are of the same color. So if you look at our tree diagram, the balls that have the same color is in the first branch and the second branch. That is to say, we are going to talk about probability of getting a yellow, yellow and a yellow, or probability of getting a blue, blue and a blue. The balls picked are of the same color. That is yellow, yellow, yellow. We are going to take this branch, we multiply by this branch, we multiply by this branch to get the probability of a yellow color. That is, we have 9 out of 15 times we have 8 out of 14, then times we have 7 out of 13, plus we have also this that contains the same color. That is going to be 6 out of 15. We multiply by this is 14, sorry, that one is going to be 5 out of 14. We multiply by 4 out of 13. And this one is going to give us, assist me with that calculator please. This one is going to give us, that is 9 over 15, 9 out of 15 times, we have 8 out of 14 times, we have 7 out of 14, and this one is going to give us 6 out of 35. Or we can simply do the upper part, which is 8, which is 9 times 8 times 7, we get 504 out of, we have 15 times 14 times 13, which gives us 2730, plus we have 6 times 5 times 6 times 5 times 4, which gives us 120 out of, we have 15 times 14 times 13, which gives us 2730. And in this case, if you take 504 out of 2730, plus we have 120 out of 2730, we are going to get 8 over 35. And everything respected, that is the answer for part 1. B, 2 balls of the ones picked are yellow. That means we are going to get the probability of the balls picked, that is 2, are what? Yellow. So again we go to our branches and try to look at where we have 2 yellow balls. And in this case here we can see we have 2 yellow, here we have 2, and where else? We also have 2 yellow balls here. So to get the probability of getting 2 yellow balls, we are going to multiply all the probabilities along this branch. We add with the probabilities along this branch. We also add the product of the probabilities along this other branch. That is to say, we are going to have that branch is going to be 9 out of 15. We multiply by 8 out of 14. We multiply by, that is yellow, and of course 1 is blue. That satisfies our question. That is 6/13. Then we are going to add with the product of the probabilities along this tree. That is, again, we begin with 9 out of 15. We multiply by 6 out of 14. Then we multiply by, we have 8/13. Then again, the last one will be here, where we have 6 out of 15 times, we have 9 out of 14 times, we have, the last one is 8 out of 13. So if we sum them up, we are going to get the answer. Anyway, that is, the first one is, we have 9 times 8 times 6, which will give us 32 out of, we have 15 times 14 times 13, which gives us, that is 15 times 14 times 13, which gives us 27/30, plus we have the other one is 9 out of 15 times 6 out of 14 times, we have 8 out of 13, and that gives us I think there is a problem there, 9 out of 15 times, okay, to go very fast, let us do the numerators. That will be 9 times 6 times 8, which is giving us 432. Everything divided by, again, if you look at this and this one is the same, that is 27/30, plus, again, this one is going to add up to 27/30. Then we do the upper part, that is 6 times 9 times 8, which gives us 432. Then if you add the LCM again is 27/30. We add the numerators, we have 432, which gives us 1296, and this can be simplified further to give you that fraction in its lowest version. Moving to our question number 4. The question reads, a school water reservoir is supplied with water by 2 pumps, that is P and Q. The probability that pump P fails is 1/10, and the probability that pump Q fails is 1/5. Question goes ahead and says, calculate the probability that Roman 1, both pumps are working, B, both pumps are not working, then C, only one pump is working, then of course number 4, at least one pump is working. So we have 2 pumps here, that is pump P, and also we have another pump, which is Q. The probability that P failing is actually 1/10. We also have the probability that it is going, or it's working, which is the remaining, that is 9 out of 10. We also have another pump, which is Q, and the probability that Q fails is 1/5. That is failing and working. That of failing is 1/5, meaning the probability that Q is not going to fail is 4 out of 5. Now, the first question, we are supposed to calculate the probability that both pumps are working. Probability that both are working. So if you look at this question clearly, you realize that the 2 probabilities are independent, meaning P failing does not influence Q from failing, or P working does not influence Q from working, and therefore the two are independent events. From what we did in our fourth principle, independent events are going to be connected using a multiplication sign. Now the first question is both pumps are working. To get the probability that both are working, we take the probability of P working, which is 9 out of 10. We multiply with the probability of Q working, which is 4 over 5. And this one is going to give us, that is 4 out of 5. And this one gives us 36 out of 50, and that fraction can be simplified further. Then Roman 2, which is part B, says both pumps are not working. That means probability that both not working. To calculate the probability that both are not working, it is P not working and Q not working. That means it's the probability of both not working, means both are going to fail. So the probability of P failing is 1 over 10. We multiply by the probability of Q failing, which is 1 over 5. And this one gives us 1 out of 50. Let us go to Roman 3. Roman 3, also known as part C, only one pump is working. So we need probability that only one is working. Only one is working. What it means is, if P is working, then Q fails. Or if Q fails, then P works. That is the probability of, that means P working but Q failing, or means addition, Q working but P failing. That is to say, P working is 9 over 10 times Q failing is 1 over 5. We add Q working is 4 over 5 out of, that is 4 over 5. We multiply by P failing, which is actually a tenth. So if you work out the first bracket, we are going to have 9 out of 50. We add 4 out of 50. And this one is going to translate to 13 out of 50, and that is the answer to that question. Then we have Roman 4, which is part D. Part D, we have at least one pump is working. Probability of at least one working. So to get the probability of at least one working, it means it is one working or both. And already we have done the calculation of at least one. Only one working is actually 13 out of 50. We can also go ahead and actually add the probability of both working, because it's one or both. Since we have two, we can say it's one and both working is actually 1 out of 50. Is it?
No.
It is both working is 36. Sorry, it is 36 out of 50. When you add the two, you realize we have 49 out of 50, which is very correct, because if you look at both not working and at least one working, it means happening for both, and actually one will give you 50 out of 50, which is 1. Now question number 5 here reads, 3 football teams, Chelsea, Tottenham and Everton, are playing in the English Premier League. The probability that Chelsea, Tottenham and Everton will qualify for the final is 2/3, 3/5 and a quarter respectively. Find the probability that only one team qualifies for the finals. B, 2 teams qualify for the finals. And lastly, at most 2 teams qualify for the finals. Now, let us have the 3 teams here. We have Chelsea, we have Tottenham, we also have Everton here. together with the probabilities of qualifying. The probability that Chelsea qualifies is actually, that is qualifying, then not qualifying, we can use a prime there, or we can say, okay, that is okay, this is 2/3 for qualifying, so let me actually use a, that is qualifying and not qualifying. So Chelsea qualifying is 2/3, Tottenham qualifying is 3/5, that is 3 out of 5, and Everton qualifying is a quarter. Again, we must know that if there is a probability of something happening, there must be a probability of something not happening. That is, if happening for Chelsea is 2/3, then a third is that they are not going to qualify. Another question, another team is that of Tottenham. Qualifying is 3/5, the not qualifying is 2 out of 5. Then Everton is a quarter, meaning the remaining is 3/4. Now, first question is, find the probability that only one team qualifies for the job, for the finals. Probability of only one qualify. To get the probability of only one qualify, we need to know that if Chelsea qualifies, it means Tottenham and Everton are not going to qualify. That is, we have, if Chelsea qualifies, then Tottenham is not going to qualify, Everton is not going to qualify. Or if it is Tottenham that qualifies, then Chelsea will not qualify, Everton will not qualify. Or if it is Everton that qualifies, then Chelsea will not qualify and Tottenham will not qualify. In that case, we are going to multiply the probabilities of all this, then we sum them up to arrive at the answer. That is, if Chelsea qualifies, we are going to have 2/3, then Tottenham not qualifying is 2 over 5, then Everton not qualifying is 3/4. We add, if Tottenham qualifies, the probability of Tottenham qualifying is 3 over 5. It means Chelsea is going to fail and also Everton is going to fail. Or again means addition. If it is Everton that qualifies, which is a quarter, then the two, that is Chelsea, is going to fail or not going to qualify times Tottenham is not going to qualify. Then we can work out that together. This is 4 times, that is 4 times 3, which is 12. Out of this is 20 times 3, which is 60 plus. We have that is 9. Out of 15 times 4 is 60. Then of course we have that is 2. Out of that is 12 times 5, which is again 60. When you add everything, since the LCM is 60, that's 12 plus 9 is going to give us 21. Then plus 2, we are going to have 23. Everything respected, that is the answer for the first one. Let us go to part B. And the part B reads, 2 teams qualify for the final, meaning we are supposed to get the probability that 2 teams qualify. Let us wrap this upper part. This is what we are going to rely on, and therefore we have to maintain it anyway. We have Chelsea, we have Tottenham and Everton. Chelsea qualifying is 2 over 3. That is qualifying. This one qualifying is 3 over 5. Then we add a quarter here and 3/4. So let us pick on. Let us wrap this part here. Let us wrap that part. 2 teams qualify for the finals. So we are supposed to go to part B and calculate the probability of 2 teams qualify To get the probability of two teams qualifying, it means if it is Chelsea and Tottenham qualifying, Everton will not qualify, and if it is Everton and Chelsea qualifying, that means the other one will not. So to analyze that in the best way for you to understand, we are going to have two teams qualifying, that is Chelsea and Tottenham qualifying, then Everton does not qualify, plus we have now Chelsea qualifying, or let us go to Tottenham qualifying, Everton qualifying, then Chelsea doesn't qualify. Then we go to if it is Chelsea that qualifies and Everton, then now Tottenham will not qualify. And in that regard, we can now start working out the question to try and get the answer to that. So Chelsea qualifying is 2/3. We multiply by Tottenham qualifying is 3/5. We multiply by Everton not qualifying, in this case is going to be 3/4. We add Tottenham and Everton qualifying is 3/5 and 1/4 respectively. Then of course Chelsea does not qualify. And then lastly we have Chelsea qualifying, that is 2/3. Everton qualifying is 1/4, but Tottenham fails to qualify, which is 2/5. Then we do the workings. Again, if we do it manually, we have 36 times 3, which is 18 out of 60, plus we have 3 out of 60 again, plus we have 4 out of 60, and this one here is going to give us, this is 21 plus 4 giving us 25 out of 60, which can of course be simplified. Then of course we go to part C. Which says at most 2 teams qualify for the finals. Probability of at most two teams, at least 2 qualify. In short, to get the probability of at most simply means it's either 2 or less. At most 2, it is 2 or less. 2 or 1, that is. And if you look at the first working and the second, you realize that at most 2, we have already done 2 teams and we have done only 1 working. And in that case, we can take the probability of only 1, only 2, and only 1, so that we can sum them up together. Qualifying is actually 25 out of 60, plus we are going to add straight the probability of only 1 qualifying, which is 23 out of 60, and in this case the total, that is 25 plus 23, is going to give us 48 over 60, and of course that fraction can be simplified into its lowest fashion. That brings us to the end of today's learning. But for more questions, those who have questions, you can go to the comment section and send your comments there, and we shall be glad to address them accordingly. Otherwise, thank you for watching and welcome.